Today we're going to review solving systems by eliminations. So the first thing we're going to do here in problem 1 is to eliminate the y's. Since 1 is a negative 1 and 1's a positive 1y, those eliminate. Then we have 3x plus 1x gives us 4x equals negative 6 plus 2 is negative 4. We're going to divide both sides by 4, and x is going to be equal to negative 1. So then we can choose either one of these equations. I'm going to go ahead and just choose the bottom equation to check this, or not to check it, but to find our y value. So x is negative 1, we just found that out, plus y equals 2. Then we're going to add 1, it's just a one-step equation, add 1 to both sides, and y is equal to 3. So we have the ordered pair of negative 1, negative 3. Now what we can do is go ahead and check it. So we can use either equation. It doesn't really matter. I can use the top equation. So this will be 3 times negative 1 is negative 3 minus 3. Is that negative 6? Yes, it is. So that checks out okay. All right, problem number 2. We're going to do the same thing, but instead of eliminating the y's, we're going to actually eliminate the x's. So those will cancel out. And then we have 1y minus 3y is negative 2y. Negative 3 minus 11 is negative 14. We're going to divide both sides by negative 2. And y is equal to 7. Then we're going to substitute, let's see. Looks like maybe the top one might be easiest. So we're going to have negative 5x, and in place of y, we're going to put 7. So plus 7 equals negative 3. Then it's just a two-step equation. Subtract 7 from both sides. So we have negative 5x equals negative 10. Divide both sides by negative 5, and x equals positive 2. So then we can check this. All right, so let's go ahead and just use the the bottom one. So 5 times 2 is 10, minus 3 times 7 is negative 21. So is 10 minus 21 negative 11? Yes, it is. So it checks out just fine. All right, let's go ahead and take a look at what we're going to do down here. Sometimes nothing will cancel out until you change something. We can use multiplication. So multiplying the entire equation, and you can use either equation, by a negative 1. Do not solve on 3 and 4. Just multiply by negative 1. So what we're going to do here is we're going to go through and multiply this top equation by negative 1. I'm just going to put it underneath this one. So we're going to have negative x minus 4y equals negative 2. So I pretty much am just wiping this equation out and not using it anymore. So then you see how the x's will now cancel out. So then we would have negative 5y equals negative 10 and so forth. We don't have to solve it. It just said multiply by negative 1, rewrite the equations, then add. So that's exactly what we did. All right, let's go ahead and take a look at number 4 here. And we're going to multiply one of the equations by negative 1. I'm just going to do that to the top one. Now, one thing that you could do is, instead of rewriting the equation, when you multiply this by negative 1, that negative 2x will become a positive 2x. That positive y will become a negative y, and that negative 6 will become a positive 6. So that's just something that you could do. Okay, so now we have 2x and 3x is 5x. Negative y and positive y, that cancels out. And now we have 6 plus 4 is 10. All right, let's go ahead and take a look at 5 and 6. It says solve on both 5 and 6 by multiplying one of the equations by a negative 1. All right, so let's go ahead and take a look. So we're going to do the whole thing on both 5 and 6. So on number 5, we're going to multiply one of the equations by negative 1. So let's just go ahead and multiply the bottom one by negative 1. So I'm going to change this to negative x, this to a negative 2y, and that to a negative 17. So 4x minus an x gives us 3x The two y's cancel out because one's a positive and now one's a negative. And 38 minus 17 is 21. All right, so then we're going to divide both sides by 3. So x is equal to 7. So I'm going to put a 7 right here. And then we're going to plug 7 in place of one of the equations. Now, when you get to this point, I never use the equation that I changed because that's where some mistakes might occur. Like you might use that negative x and then you may use a positive 2y and then a positive 17 and forget about the negative. Anyway, so what I do is I'm going to go ahead and use this top equation right there. So I have 4 times 7 because x is 7, so that gives us 28 plus 2y equals 38. Then I'm going to subtract 28 from both sides. So I have 2y equals 10. Divide both sides by 2, and y equals 5. So then we can check this. And again, I'm just going to use that top equation again. So 4 times 7 is 28 plus 2 times 5 is 10. So is 28 plus 10 38? Yes, it is. So that checks out. All right, let's go ahead and go on to number 6. I'm just going to go ahead and since in problem 5, I changed the bottom equation, I'm going to change the top equation. So I'm going to change this positive 2x to a negative 2x, that negative 3y to a positive 3y, and that positive 4 to a negative 4. So the x's cancel out, so I have 3y minus y gives me 2y. And negative 4 plus 18 is 14. So I'm going to divide by 2. So y equals 7. All right, now I'm going to substitute here. So I'm going to put 7. Again, I changed the top equation. So I'm going to put the 7 in that bottom equation. So I'm going to have 2 times x is 2x minus, in place of y, I put 7 equals 18. Now it's just a two-step equation. We'll add 7 to both sides. So 2x is equal to 25. Divide by 2, and x is equal to 12.5. So that is something kind of different to get a decimal there. But that is the right answer. So we could go ahead and plug in. I'm going to use the bottom equation. So 2 times 12.5, well, that would give us 25 minus 7. And is 25 minus 7 18? Yes, it is. So that actually checks out just fine. Now what we're going to do is solve the system of equations by eliminating like terms using a common multiple. So we're going to multiply one of the equations to get a multiple that will cancel out. Then find the solution, which is the ordered pair. And don't forget to check it. So I think what I'm going to do on problem 7, since I have a 2y here, I have a 2y right here. If this becomes a negative 2y, then it cancels out. So that's what I'm going to do. I'm going to multiply this bottom equation by a 2. All right, so this is what's going to happen. That top equation is going to stay the same. I'm just going to draw an arrow right there. So this is 8x plus 2y equals 16. And then this one, 2 times 5x is 10x. 2 times negative y is negative 2y equals, now here's where a mistake occurs quite a bit. Don't forget to multiply 2 by the 28 as well. So that will give you 56. All right, so now I can eliminate the y's, and I have 8x plus 10x is 18x equals, and that's going to be 72. And then I divide by 18, and x is going to be equal to 4. All right, so now it now really doesn't matter what equation I use. You actually have an option of 4 equations that you could put that 4 in place of x. I would not use, well, actually 3 equations, because the top equation is the same. The bottom equation is now doubled. So those are bigger numbers. So I think what I would probably do is go back and use this bottom original equation. So that's what I'm going to do. I'm going to take this equation over here. So it's going to be 5 times x. So 5 times 4 is 20 minus y equals 28. Then I'm going to subtract 20. So I have negative y equals 8. Now this is a negative 1y. So I divide both sides by negative 1. And y equals negative 8. So I have the order pair of 4 and negative 8. Now I'm going to check it. So I'm going to do a little squiggly. This is going to be my check. And again, it doesn't matter. I'm just going to go ahead and use the top equation, the 8x plus 2y equals 16. So x is 4. So 8 times 4, that gives us 32. Plus 2 times negative 8 is negative 16. So 32 basically minus 16 gives us 16. So that checks out just fine. All right, let's go see what we're going to do on 8, 9, and 10. So it says to try these. So let's go ahead and take a look at number 8. I guess it really doesn't matter. We could eliminate the x's by multiplying this equation by a 5. We could eliminate the y's by multiplying that equation by a 2. So again, it really doesn't matter what you do. Some people like to eliminate the x's no matter if it's a bigger number that they're multiplying by or not, just because x appears first. I'm just going to go ahead and eliminate the x's. So I'm going to multiply this right here by a 5. So it's going to become 5 times x is 5x. 5 times 6 is 30. And 5 times 16 gives us negative 80. The bottom one stays the same, so negative 5x minus 3y equals negative 28. So the x's cancel out, so this will be 30 minus 3 is 27y equals, and that'll be 8, negative 108. Divide both sides by 27, and y is going to be equal to, I believe, negative 4. 8, 9, 10. Yep, so that's it. All right, so now y is negative 4. So now we are going to, I'm just going to go ahead and use this bottom equation right now to put negative 4 in place of y. So I'm going to have negative 5x. And basically that's a negative 3y. So negative 3 times negative 4 is positive 12. Equals negative 28. Then it's a two-step equation, so I just subtract 12 from both sides. So I have negative 5x equals, and that'll be negative 40. Divide both sides by negative 5, and x equals 8. All right, then of course we always want to check it. So I'll just use the top original equation. X plus 6y equals negative 16. So x is 8. plus 6 times negative 4, that's minus 24. Does that give us a negative 16? So 8 minus 24 equals negative 16. Yes, it does. All right, so let's go ahead and take a look at problem 9. And, I can get rid of the x's. I think that would be easiest. Because if I try to get rid of the y's, the common multiple would be 70. So I would have to change both equations. Like I would have to multiply the top equation by a 7 and the bottom equation by 10. We are not going to do that. Let's kind of go the easier route. So what we're going to do is multiply this top equation by 2 because we're going to eliminate the x's. So this will make it 8x minus 20y equals 2 times 6 is 12. The bottom equation stays the same. So this is a negative 8x plus 7y equals negative 25. So the x's cancel out. So negative 20 plus 7 is going to give us negative 13y. And then 12 minus 25 is negative 13. And we're going to divide both sides by negative 13. By negative 13. So y equals 1. So we're going to put a 1 there. Then we are going to substitute 1 in place of y. And let's go ahead and just use that equation right there. So we're going to have negative 8x. And 7 times 1 is 7. Equals negative 25. Then we're going to subtract 7 from both sides. So we have negative 8x equals negative 32. Divide both sides by negative 8. And x equals 4. So we have the order pair of 4, 1. So now I'm going to check it. I'm just going to go ahead and use that bottom equation. So negative 8 times 4 is negative 32. 7 times 1 is 7. Plus 7. Does that give us negative 25? And yes, it does. All right, let's look at the last one. Now on this last one, it says, now you'll solve the system of equations by eliminating like terms using common multiples on both equations. So on this one, we can either get 12s for right here, the x's. So this would be times 4, this would be times 3. Or we could eliminate using 6's for the y's. Like you would have to multiply the top equation by a 3 and the bottom equation by like a negative 2. So it really doesn't matter what you do. We can go ahead and, I guess, eliminate the x's. Since we've been eliminating the y's on the previous two, let's go ahead and eliminate the x's. So we're going to multiply this one by 4. So 4 times 3x is 12x. 4 times negative 2 is negative 8y. And 4 times 7 is 28. Then we're going to multiply this bottom one by 3. So 3 times negative 4 is negative 12x. 3 times negative 3y is negative 9y. And 3 times 19 gives us 57. All right. So our x's cancel out. So negative 8 and negative 9 is negative 17y. Equals, and this will be 85. And then we're going to divide by negative 17. So y equals -5. All right, so now I'm going to substitute -5 in place of, I want to do the top equation right there. So now I'm going to come over here. So this will be 3x, and that's -2 times -5. Because remember, I'm putting -5 in place of y right here. So -2 times -5 is +10 equals 7. Then I subtract 10 from both sides. So 3x equals -3. Divide both sides by 3. And x equals -1. So now let's check it. This is our check. So I'm just going to use the bottom equation. So -4 times -1 is 4. And -3 times -5 is 15. Is 4 plus 15 19? Yes, it is. So everything checks out just fine on that particular problem.